So hi and welcome to another DCG tutorial. So this question we're going to be doing the Assemblies question from the 2014 paper. So 2014 section C question C5. So as always, going to read through the question first. So C5 part A. Details of a miniature bench vise are shown in the figure C5. The vise is adjustable and can be tilted and rotated. A parts list and a 3D graphic of the parts are also given. Draw a full-size section elevation on AA of the vise in a horizontal position, showing the parts fully assembled and with the jaw faces 30 mm apart. Okay, it's important. We have a constraint in the question already. All fillets are 6 mm. All chamfers are 2 by 45 degrees. Any omitted dimensions may be estimated. Okay, sometimes I leave them out. Part B. Determine on your drawing the position of point P when the jaws are fully closed and the vise is tilted fully to the left. So there's our point P. Okay, so looking at the question first, we have all our parts here, detailed orthographic views and all the measurements you'll need. Any ones again that are omitted, you estimate. And very important is a list of parts here, okay? And it gives you names for each. So part 1 is your moving jaw. Part 2 is your base, alright. Part 3 is clamping nut, 4 swivel shaft, 5 retaining screw, 6 adjusting screw, 7 crossbar nut, and 8 fixed jaw. Okay, so from those names you can actually help you to assemble the parts. Now, one of the tips I do for this question is the part you start off with, I tend to recommend is the part with the sectional view going through it. So in this case that's part 1, so that's your moving jaw. Okay, so I do that sectional elevation first, okay, keep it nice and light, and then I'd work off that then. Alright, now I'm going to start this near the top of the page, just give us plenty of room. So, nice, like the Assemblies questions because basically you're just copying, drawing what's given there on the sheet. Yeah, so we're drawing the elevation of part 1 with the sectional view, so won't be too much commentary on this, just going to fly through it. So the curve on the jaw is radius 60, so I'm just going to mark in the 60 there, pin at the compass, lid at the edge, and draw up. Radius 60 curve. So that's finishing off the jaw there for me. Okay. We need a center line going through here. And it is radius 10 on that 20. Keep everything as light as you can at the start, and once we start assembling we can figure out what goes where. So we have a diameter 12 and a diameter 16 hole coming in here from the right, so we're going to put in both of those. We have our central line, so we can just measure the radiuses up, so 12 and 16, that gives you 6 and 8. Measurements are 2 9mm from the right hand side here, so I'm measuring 9 and 9. So the second 9 is where the diameter 16 stops, and this 9 here is for a center line. and the hole there is M8, so M8 means 4 either side. Come in a mill, just to show that it's tapped. And it's tapped up to the diameter 16. Are dead center of the hole, so therefore with the sectional view, those holes will be put in as strong lines. Alright, so that is part 1, and part 1 was the moving jaw. So to work off assemblies, you need to be looking at measurements. And it's a vice, so obviously the other jaw, so in this case the fixed jaw, part 8, is going to be opposite your moving jaw. And the constraint was 30mm apart, so that means you need to make sure there's a 30mm gap between your jaws. So if you look at part 8, it is the same radius as the 60, it's a 40mm, so we have the same height here, 40mm, and then we have our diameter 20 hole there. Okay, it matches up with the slot that's cut into the moving jaw. Okay, so what I'm going to do is going to measure 30mm from the fixed jaw, or sorry, from the moving jaw, and start drawing in the fixed jaw, and everything works off that. Off part 8, everything's attached to part 8, so that'll give us the rest of the drawing. So 30mm from your moving jaw, that's a 30mm gap. That is now where I can start my other jaw of the vice. So the width of it isn't the full 30, it's actually 28mm, so we're going to measure over 28. And then our radius 60 that we had here is actually coming from the opposite direction, so this is my 28 here, so I need to mark the center over to the right hand side here. Pin there, lead here, and that is my curve. Okay, so that is start of the jaw for the moving part, okay, or so for the fixed jaw. From the edge there, we're going in 6mm. And then from that 6mm you have your 22, which we had there, and then another 22 because that's the center line. And draw them lightly down. And they're going down further. They're going down further than the actual moving jaw, so let's draw them down. And the height for that was 20, 20, and then another 20, so let's mark another 20 below here. Mark that in, and draw that lightly across. That'll give me the base of the fixed jaw. The fixed jaw is on the outside of this moving jaw. The moving jaw is moving inside of it. So we're going to have that front face cut off and hidden detail at the back. We have a diameter 20 hole in the center we need to put in, because you'll see that at the back. And also we need to put in the M16 hole at the bottom. Okay, so on that center line, it's right in here, we have that diameter 20 or radius 10 as we have here. A hole in the center here, so that is 8 either side. And draw, and also draw them lightly at first off, so they're going up as far as that first 20. I need to measure 1mm in either side to show that it is a tapped hole. Now let's start drawing a few things in strong, seeing as we have two parts assembled there now. and we know that these slots are going to be strong, and even if there's bars going through them, which there is, they're going to be strong as well. So I'll just put in a few bits strong just so it stands out. Now leave the hatching to the end. So let's work on the inner workings inside here rather than moving on to the base. So looking at the part 8 here, where we have that M16 hole, look at the other parts that has an M16 thread on it. So for this case we have part 4, and part 4 is called the swivel shaft. So if that M16 is threaded up into the base of the fixed jaw, then that's what it's going to swivel about. And then that is radius 20. Look at the base, part 2 has a radius 20 curve cut into it, arc cut into it. So it's going to fit down into that and swivel around it. So let's work on the inner workings here of part number 1. Okay, so device, so therefore this part here, part number 6, is your adjusting screw. It needs to be tightened and loosened and so on. That's M12. We have diameter 12 hole here. Okay, we have diameter 16 countersink on the top of it. So let's see, these are diameter 16s. We have an M8 hole here and an M8 thread on part 5, which is your retaining screw. So I think we can start applying them. Also, part number 7 here is your crossbar nut, which is diameter 20, similar enough to the hole going through part number 8 down here. And also it has an M12 hole inside it so that you can actually thread your adjusting screw through it. So part 7 is going to fit through part 8 there, and then part 6 is going to fit through that. Okay. Continue that over so we can see how far part 6 goes, or part 7, or part 6, yeah, part 6 goes. So bring that over. So we're going to mark it so that the adjusting screw, this diameter 22, stops dead at the edge here. So then we have diameter 16, diameter 10, diameter 16, and add them all up is your 18. We already had 18 inside here. So those little sections here, you're going to see that. And also this is going to be cut right through the center as well, so we're going to see that. So we already have our 16, so now we need our diameter 10, so let's go 5 mil either side. That's in as far as 18, which we have here already. And then it's M12, so that 12 we need to measure down a mil from the top and a mil from the bottom. So 1 mil there, 1 mil here, and bring them over to show that it's threaded. Now let's start putting in some length. So that is our datum point here. So the adjusting screw, that part number 6, is touching off the face here on the outside of part 1. Okay, so from that then we can mark our measurement. So we already have that 18 put in, and that's to here. Then the full length of it over is 112 mil. So we'll measure that over from our 18 here. So 112 mil. So 112 from the 18 mark in. And to me that's lining up right there, so that's nice enough. So that already have that line put in. And this is in. Draw my curve down there. And here, that should give me the fillet at the end. So that is the end of part number 6. and M12 all the way along, and then let's start putting on the outside part of it. So and before I draw that in strong, I'm just going to put in the screw that's going up here through the M8 thread. So looking at the drawing, part 6 is going through part 7 there, and part 7 is going to be cut right down the middle, and it's going to be behind part 6. Part 6 then is going to be strong, it's going to be in front, and there shouldn't be anything else then in front of that. So we can go about drawing that in strong. So let's move on now to our M16 down here. So that was M16, and it was part 4 has M16 on it, and that is the swivel shaft, and the threaded section of it is 20mm high, which is the depth of that hole. So therefore the part 4 must start at the top there. So we go down 20, and then the full length down is 45, so you can extend that down. Extend that 16 straight down. And the full height down was 45mm. So that's our 45mm down, and it is radius 20. And we have a central line going right down through the middle there, so that was sitting off the edge here, put the pin there, led through the central line. That will give me the center for the radius 20 circle, or arc in this case, it's not a full circle. Okay, and that is part 4 done. Again, that is a bar and so on, so that won't be cut in the hatching. Center, which we found here, is going to be the top of the base. So bring that straight across, and then we can start putting in measurements. So next thing now, rather than go and draw that in strong, I'm going to put the clamp, which is part 3, above that. So you saw, if you look at part 3, you see that it is M70 and it's down 15, so it's going to come down on that 70 here, and it's going to be down to 15 mil, the threaded bar, and the hole in it matches up, lines up with the center here, lines up with the top. Okay, so from that center line across here, from the top of the base, we're going to measure up 10 mil, and we're going to use our 15 line. So measure up 10 mil, see where it ends on that sphere part of part 4. And it is 15 down, and the diameter of it is 90, so we'll go 45 either side. There are chamfers on both sides of it. So on the top here and at the bottom, and that is pretty much it done. So if we're measuring 2 mil there, and 2 mil here, and draw them lightly up, we'll get the 2 mil at the top as well. So that is part 3 put in. So let's start drawing in strong. It's been cut. So you don't hatch the back of the hole here because it's not being cut. Okay, that's the back of it, you see that. Same with the hole here, you don't see the back of it is being cut because you'll actually see the back of it. Next rule is that 2 parts touching each other, the hatching must change direction. And if there's multiple parts, like 3 or 4, then to make them stand out, you differ in the gaps between the hatching. So in this case, we're in 45 degrees to the right for the base, so for the clamp, we'll go 45 degrees to the left hand side. So that's part A of the question done. If you start running out of time, remember we only have 25 minutes per question, so if you start running out a bit of time, leave the hatching and you might gain a bit of time with short questions. It is a long question, but it is a nice question and there isn't too much to be put into it. So you can leave the hatching to the end and move on to part B. So part B, determine on your drawing the position of point P when the jaws are fully closed and the vice is tilted fully to the left. So point P. Now it doesn't really stand out too much in the drawing, but point P is this point here. Okay, so back to point P. So what they're saying is find the position of point P when the jaws are fully closed and the vice is tilted fully to the left. So we drew it with 30 mm gap between the two jaws of the vice. This is the fixed jaw, that is the moving jaw. So the moving jaw must move 30 mm to the left first to close. So that means point P is going to move 30 mm to the left first to close. So let's move that over to the left 30 mm. That's our 30 mm gap. So that's position of point P when the jaws are fully closed, but it's fully closed and tilted to the left. So to tilt it to the left, this swivel, this ball here, is going to have to tilt down at an angle to the left hand side. So where does it stop? How does it stop? It stops when that curve reaches the clamp here, and when that line, that straight part of the shaft, is resting on part number 3. So what we need to know is the angle between the center here so the angle between the center and that point, and when it comes to a rest, which is down here, that's when it hits off the clamp. So that is exactly the angle that it rotates. That is as far as it can rotate to move down to the right hand, or to the left hand side. So if we get that angle, join the center here to point P1, step off that angle, and we'll be given how far point P moves. So it's rotating around the center here, so join point P1 back to the center. Going to use a protractor now to measure that angle. So we have 40, let's extend it lightly. One, 2, 3 is around 43 degrees. So if we step that off from our point P1, basically you're rotating it down at that angle. So 41, 2, 3 degrees. That's my point there. So it's going to be on that line somewhere, so to figure out where it is, it's rotating around the center. So pin at the center, lead at P1, and rotate down till you meet your line. And this is position of point P. So the angle here is the same as the angle from P1 to point P2 down there. So that's your final position for point B when the vise is closed and tilted fully to the left hand side. So there's the same angle here. So that is the assemblies question done. It is a nice question in that there isn't too much theory behind it, such as the cams and so on, and everything's done up for you on the page. Just a matter of assembling it, figure out what goes where, and also knowing what to hatch and what not to hatch. Okay, so I hope that helped. If it did, leave a like, and if you want to see certain questions done, leave a comment in the comment section below. Okay, thank you and good luck.